Good morning, students. Today we shall learn a very new topic from sequences in series, that is sum to n terms of a spatial series. And let us try to find the formula to find the sum of a spatial series. Okay, so the first one is Sn, which is given as 1 plus 2 plus 3 plus 4 till the nth term. So as you know that this particular number is nothing but the series of n natural numbers, and we need to find the sum of this particular series. So what exactly we do here? First of all, we'll find the first term. If you look at the first term, which is a represented as 1 here, and the common difference d is nothing but 2 minus 1, which is also 1. That means this particular series is nothing but in arithmetic progression. Okay, so the formula for finding the sum of AB is nothing but Sn, which is given by n by 2, 2a plus n minus 1 into d, right? That is 2a plus n minus 1 into d. Now, as you know, from the given series, the last term is already known, which is n. So instead of this formula, you can simply derive another one for finding the sum using the last term. So you can use this formula, that is Sn equals to n by 2 a plus an, or n by 2 a plus l, where l is the last term. Okay, so a is given as 1 here. Okay, and the common difference is d. By using this formula, you get the value as n into n plus 1 by 2. Whereas if you use this formula or this one, both are same actually, l equals to a n only, you get n by 2 into a is 1 and l is n. So rearranging it, you get n into n plus 1 by 2. That is one and the same thing. Okay, so either you use this way or this way, both are the correct ones. The second series is 1 squared plus 2a squared plus 3a squared plus till n squared. This is called as the squares of natural numbers. Okay, so squares of the natural numbers. And for this derivation, what is the derivation of this? The derivation of this will give you n into n plus 1 to n plus 1 by 6. So let's start with a solution. For finding the sum of the squares of some of the squares of natural numbers, we need to use the identity that is called as k cube minus k minus 1 whole cube. So here, k minus 1 whole cube, they have used the formula of a minus b whole cube, that is a cube minus b cube minus ab 3ab a minus b. Okay, so this will give you a cube, that is k here, so k cube minus 1 cube means 1 minus 3ab a minus b, so 3k into 1, that is 3k, and a minus b is k minus 1. So it will give you k cube minus 1 minus 3k squared plus 3k, and here k cube, so k cube minus k cube, this will get cancelled. What do you get here? 3k squared minus 3k plus 1, 3k squared minus 3k plus 1. Okay, if you take minus sign, common here. Because it was k cube minus in the bracket here. Okay, so it becomes plus 1 plus 3k, and this will be minus 3k. Minus 3k. Now it will be 3k squared minus 3k plus 1 after dissolving the brackets. Okay, so after taking the values, let's take the values of k as the natural number, that is 1 till n. We get 1 cube. Just place k equals to 1 in this identity. 1 cube minus 0, that is 1 minus 1 becomes 0. So 1 cube minus 0 cube is equals to 3. Now placing the same thing here also. So it becomes 3, 1 square minus 3 into 1 plus 1. Similarly for 2, 2 cube minus 1 cube, 3 2a square minus 3 into 2 plus 1. Similarly, till we go till n cube minus n minus whole cube. 1 whole cube is equals to 3n square minus 3n plus 1, because in place of k we have placed n here. Now by adding both sides, column wise, if you add the numbers, you get n cube minus 0 cube is equals to 3. Look at the numbers here. It is 1 square, 2 square, 3 square till n square. So it will be 1 square, 2 square, 3. Separately we are adding, okay? So the square ones will come into 3n square category. Then minus 3n, so 3 minus 3 into n. N means here 1, 2, 3, okay? Till n we are going. So the sum of the series of natural numbers, that is 1 plus 2 plus 3 plus n. Okay, and 1 is repeating n times. 1 1 1 till 1 here, so it is simply plus n. So sigma of n, that means only 1 is repeating out here, okay? 1 2 3 till n. If you write capital N, which is a natural number, so 1 plus 2 plus 3 plus n. Now if you see here, writing in the summation format, this is the sign of summation, sigma. So n cube, from here left hand side we are left with n cube is equals to 3, summation of k is equals to 1 till n, k square, because it is a square form, minus 3 here, minus 3 here, and then summation of k equals to 1 till n, and it is only k because it is sum of the series of natural numbers, so only k, n plus n, the last one. Now just transposing the values here. So if you take 3 multiplying by 3 here, no need to multiply by 3. What you do here is so 3 Sn means what? Taking this value as 3, and we need to find the value of some of these squares here. So I'm representing the k square as Sn. So leaving this to the left hand side and shifting everything to the right hand side. So n cube here minus 3 summation of k equals to 1 till nk will go to the left hand side, becomes plus here, and this plus n will go to the left, becomes minus. Okay, so summation of k equals to 1 till n into k is nothing but, just now we have proved, that is some of the series of natural numbers, that is n into n plus 1 by 2. Okay, and then solving it, what you will get here after solving, take the 2 as LCMs, so 2n cube, you can write this as n into n square, because here is minus n, so taking minus n common here, so if you take n common, it becomes n square minus 1 plus 3 n by 2 n plus 1 as it is. So this will remains unchanged here, minus n will go with n cube, you get this value after factorization, and then n into n plus 1 and n minus 1, because here the value of expansion of n square minus 1 is n plus 1 and minus 1, using the identity a square minus b square. So n into n plus 1, if you take common, so I'll write one more step here, n into n plus 1 and minus 1 plus 3 n by 2 n plus 1. So to the left of plus sign and to the right of plus sign we have n plus 1, so we take n into n plus 1 common, okay, because n is here also. So n into n plus 1 common, you will get n minus 1 from here, n plus 3 by 2. After solving this, you get the value as n into n plus 1 to n plus 1 by 6, because this 3 will go to the denominator, multiplying with 2 gives you 6. So that's all from the 2 special series. We'll discuss the next one in the next virtual class. Thank you.